Hey guys, today I'm going to take an in-depth look at the new geometry script plugin that's featured heavily in the new Lyra multiplayer shooter project that was recently released by Epic. So to use the geometry script plugin, first you have to go to your plugins options and enable it. I'll just find that here. And you get a warning here about an experimental version. I'll say yes, and I'll restart my editor. Back in the editor, the first thing I'll do is make a new blueprint. And in the all classes here, I'll find the generated dynamic mesh actor. And I'm going to call this one my generated mesh parent. And I'll put in some functions in the parent class that'll apply to all the different tools that I might make. But for now, I'll just make my first tool by right-clicking, create a child blueprint. And I'm going to call this one my basic wall tool. Okay, I'll open that up here, and on the event graph, I'll make a new function here for on rebuild generated mesh. And I'll drag from target mesh here, and I'll promote this to a variable called dynamic mesh. So I can easily reference that later. And what I'm going to do is just make a sequence here so that everything is very easy to read. And what we'll do off the sequence pin, the first thing I'm going to do is I want to start by appending. And I can append any one of these primitives here from the engine, but I want to make sort of a wall shape to start with, so I'm just going to append a box. And for the target mesh here, I need to plug in my dynamic mesh reference. And I want the user of the tool to be able to edit or adjust the size of the box in sort of real time in the editor. So what I want to do here is introduce a new variable called wall size, and I'll set that to a vector, and I'll make it instance editable, and I'll say show 3D widget here, and I'll set a default value. We'll set the wall size, maybe the width could be like 200, and the Y we'll use as the thickness will be 25, and the Z will be the height. We'll say maybe 150. And okay, so now what I want to do is drag this wall size variable, we'll split the pin and plug all these components into the dimensions. All right, and if I compile, take a look at the viewport here, this is our piece of dynamic mesh that we've created so far in those default dimensions. And if I drag one of those into our scene here, I can grab this handle, it's over here, and it's got this wall size label on it here. I can drag this around and we can adjust the wall size in real time in the editor with this handle. All right, so that's the first step. And the next thing I want to do here is create a cutout. So for the next pin here, what I'm going to do is say allocate a compute mesh. And this is like a scratch pad of sorts. I'm going to make a mesh that I'm then going to use in another operation, a Boolean operation against our original mesh. So what I want to do here is I want to say append once again. And I could just append a box, and we could just cut out a box from a box kind of thing. But I'm going to go one step further and make it a little bit better. And I'm going to say append a rectangle XY. And what I'll do here now is split the transform pin. And I'm going to set this rotation on the x-axis to 90, and then set up the dimensions for the height and the width. And for the height and the width, I want the user to be able to edit those on the fly as well. So I'll make a new variable here called cutout size. And again, we'll say instance editable and show 3D widget. And I'll compile and make some default values here. We'll say it's, maybe the default could be just like 50 in all the axes. And I'll drag that over here, get the variable, we'll split the pin, and I'm going to plug in the x here for the dimension x. And it's a 2D rectangle that we're making here. So in 2D, y is the height, and so we want to plug in the z, which is our cutout height, into the dimension y. Okay, so the next thing that I want to do is I'll save this mesh, just promote it to a variable here. We'll call this the cutout mesh. So just to make it easier to reference here in the next steps. So I'll add another pin to the sequence here, and the next thing I'm going to do is apply extrude, a mesh extrude, and we'll plug in the cutout mesh. All right, and then what I want to do is drag back here from the options and say make, and I can make these options and we can set the distance and the direction. So we want to extrude in the Y dimension because that's the thickness of our walls. So I'll just change this back to 0, change the Y to a 1, and the extrude distance, I'm just going to drag this cutout size variable. We'll split the pin, and the Y component will be our extrude distance. So we'll be able to adjust that on the fly with our cutout size handle. All right, and after doing the extrusion here, I'm going to add another pin here. I'll just move this out of the way. And the next step is going to be apply a mesh Boolean. And what I'll do here is say the target mesh will be our dynamic mesh. And what I'll do here is we'll just actually set the cutout mesh to be the result of this extrusion node so that I can grab cutout mesh again here and use that as our tool mesh. Okay, and I want to be able to adjust the location of our cutout on the fly here, so we'll take our tool transform, split the pin, and for the location here, I'll drag back, say promote to variable, and call this cutout location. All right, and what I'll do here for the location is we'll say instance editable, show a 3D widget, and we'll make it a default value of maybe just a Z value of 50, so it's up off of the ground sum amount. And the operation here is going to be a subtraction, and we're going to save the result of this node to our dynamic mesh. All right. So we'll just comment these up here. Create wall, create cutout, extrude cutout, apply cutout Boolean. All right, and let's take a look here. We'll compile, look in the viewport here, see what we've got. And so far, we've got our cutout started here. And if we look in our live view here in the world, we can adjust our location of the cutout here. And we could also adjust the size of the cutout. All right. Oops. Perfect. So the next thing that I'm going to do here then, we'll just move the cutout all the way through here. What I want to do is introduce the ability to make a rounded cutout. And it's relatively easy. What I'm going to do then is we'll go to where we create the cutout, and we'll branch off here depending on if we're going to make it rounded or not. So we'll add a variable here. We'll say is cutout rounded, question mark. And I'll make that a Boolean, and we'll get a branch from that right here. Okay, and so if it's not a rounded cutout, then basically we want to do what we're doing already. So we'll set up our false to that one. And I'll just grab all of these nodes here, duplicate up here, and we'll plug in our true node over here. And I'll just adjust the comment here. We'll create a rounded cutout. And what I'll do is delete this node, the append rectangle node, and we'll make a new one here called append rounded rectangle XY. And I need to do the same transformation here. I'll split the pin on the transform and set the rotation on the X to 90. We'll just make a bit more room here and move these up. And I'll plug in the cutout size X and the Z for the dimension Y. And now we've also got another variable here, corner radius, that we should promote to a variable. And I'll set that to instance editable as well. And I'll also promote this steps around. So if it's a little bit too choppy or you want to add resolution to corners, you can do that as well. So promote to variable, instance editable. All right, and the target mesh here, we need to plug into the cutout mesh. And so now we're setting the cutout mesh to either a rounded rectangle or a square rectangle based on this Boolean. And we'll make sure that that's instance editable as well, is cutout rounded. And we'll compile here, and let's take a look at what we have so far. We'll say is cutout rounded, and there we go. All right, and so we can also change the corner radius here. We could say make this 15 or 25. We could change let's grab the handle here. Now it's like an archway or something like that. Okay, so that's a great start. Let's see what we're going to do next here. I'll just straighten these out a little bit here. All right, next we'll take a look at adding bevels. So this is pretty simple as well here. I'm just going to make a new variable called is beveled, question mark. And we'll make another pin on the sequence here, and I'll make a branch down here. All right, and we'll drag this is beveled, and we'll make that instance editable as well. And now if it's true, we want to go ahead and apply our beveling. And what we want to do is make 3 nodes here. So the first one is compute polygroups from angle threshold. And what we'll do here is set, first of all, we need to plug in the target mesh, our dynamic mesh. And I'm just going to put the crease angle here a little bit higher. I'm going to set this to 25. Okay, and the next node that I want to do here is apply mesh polygroup bevel. And so we'll just plug in this target mesh over here. And for the options, I'll split the pin, and we want to set a bevel distance here according to user input. So I'll drag back from that, promote to a variable. We'll just call it bevel amount. And I'll set that to instance editable. All right, and then the next node that we want to make here is compute split normals. And I'll plug that in as well here, the target mesh. And I'll just split this pin here, split options. And I'm going to increase this angle as well here to 25. All right, and then when that's done, we want to set our dynamic mesh. And we're going to set it to the output of this target mesh. Okay, we'll just comment this up here. Do bevels. All right, and we'll take a look at that. So I'll just select here is beveled, and you can see our bevels are applied. We'll say bevel amount maybe 5, just to show an extreme amount here, so you can see that happening. And I'll set that back to 1. Okay, and let's say I'll uncheck that for now. The next thing I want to do here is I want to set up materials for this. So what I'll do is make a couple variables here first. We'll say wall material, and I'll make that a material interface object. And I'll select instance editable for this, and I'm going to duplicate this and make another one here called cutout material. Okay, and so what I want to do here is I'll add another pin to my sequence. I'm just going to drag all this down here, and I want to say configure material set. All right, so what I need to do here is drag back from new material set and make an array. and we'll add a second pin to that array, and I'll drag up the wall material to 0 and the cutout material to 1. And then I'm going to go back up to where we extrude our cutout just before we apply the cutout Boolean, and we'll remap the material IDs. So just after applying the mesh extrude here, we'll drag from this target mesh, remap material IDs, and we'll plug that in like that. And we want to remap from 0 to 1. Okay, and so let's check it out here. I think I don't have any materials in the project, so I'll just have to go to Add, Feature, Content Pack. We'll add Content, Starter Content here. And so now I can grab, let's see here, we'll set these materials. Wall material, we'll just set that to, how about basic wall? And cutout material to basic floor. All right, so now we can see we've applied a different material in our cutout than the wall itself. And so if I drag this, let's say we don't cut out the entire amount, we're making just an inset, we can easily see that second material is applied there. Let's see what's next. Okay, what I'll do is, just for good measure here, we'll recompute the UVs. So I'll just comment this here. We'll say set up materials. And I'll add one more pin to the sequence here. We'll drag down here and I'll say grab UVs, recompute mesh UVs, and drag in the dynamic mesh reference here. And we'll also scale the UVs and offer the opportunity for the user to change the scale on the fly. So scale mesh UVs. And for the scale amount here, I'll split the pin here, and I'll just drag back from these and say promote to variable. We'll say UV scale X, instance editable, and same thing here, UV scale Y, instance editable. And I'll just, we'll set these default values as well, so that maybe they'll just be 1 to start with. All right. Recompute and scale UVs. And so we'll just check that out real quick here. Let's say we set this to something with a pattern like brick. Okay, so we're getting the bricks, but they're really very small here. So we'll set the UV scale would be something like 0.1 by 0.1, or even less there, maybe like 0.05, 0.05, something like that. We'll set the outside to something else here, maybe like this brick. All right. Yeah, so that's the basic idea. And so now you can adjust UV scaling on the finished mesh in that fashion, if needed. Because at this point, you could use this not necessarily for a wall, like maybe make the width something much bigger here. Whoops, I think I went negative on that. There we go. You make the width something much bigger. Let's say your cutout size much bigger, and the location. Maybe if this is some area the player walks into to get a power up or a portal or something like this. So it doesn't have to necessarily be a wall. And now you might have to pay more attention to something like the UVs or the scaling or whatnot. So I'll pretty much call that a wrap on the tool, and we'll move on to the functions that we need to create in the parent to make this into a static mesh. So I'll open up the generated mesh parent class here, and the first thing I'll do is make a new custom event, and I'll call this one generate new static mesh. All right, and so what I want to do here is grab the dynamic mesh component And from that, I'm going to say get dynamic mesh. And I want to create a unique asset path and name. So I'm going to say create unique new asset path name. And for the asset folder path, I'm going to put in here /game. But I'm going to drag back from that, say promote to variable, and I'll say instance editable. So the user can choose a different folder path if they want. And then for the base asset name, I'm going to right click and say self, get a reference to self, and get display name. So whatever the name of the tool is that you're using, it's going to call your generated mesh, your static mesh, I should say. Basically that name followed by a handful of random characters, so you don't have to worry about duplicates or anything like that. Okay, so next what I want to do is on success here, we're going to find a node called create new static mesh asset from mesh. And I'll plug in the dynamic mesh here that we retrieved, and the unique asset and path name. All right, and then I want to drag back from the options here. Actually, I need to say make. And we'll make those options, and I'll just drop down here and say on collision we want to say use complex collision as simple. So it'll query the bounds of the mesh to create a new simple collision for this static mesh. Okay, next I'm going to promote this static mesh asset to variable here, and I'll say instance editable. And we'll set that on success. And then I want to go ahead and set materials that we may have set up on the tool to apply to this static mesh that we're creating. So what I want to do is just get the dynamic mesh component again here, and I'll say get materials. This will give us a list of all the materials that are used, an array. So I'll say for each, and we'll iterate through the array here. And for each material that there is in the dynamic mesh, we'll grab our static mesh here and say set material, plug that into the loop body, and the array index to material index, and the array element to the new material. All right, and so that's pretty much it for that one. I'm going to comment this here and call it generate new static mesh. And I want to make one more event in here, custom event called update static mesh. And I'll make that call in editor as well, so we can click a button in the editor to run that. And I'm going to grab the dynamic mesh component again, say get dynamic mesh. And on the return value from that, I want to say copy mesh to static mesh. And the to static mesh asset will be this static mesh asset variable. And then I want to set the materials again in case we updated the materials. So I'll just grab these nodes from up here, duplicate them down here, and plug this in from on success. And for the set material target here will be the static mesh asset. All right, and so I'll comment that. It's pretty much done. We'll say update static mesh. All right, and we'll check it out here. I also forgot here on the generate new static mesh custom event, I needed to set call in editor, and so that we can run this event by clicking a button in the editor. All right, I'll compile that and we will check it out here. I'm going to find my tool in the world here. And what I'll do is first need to set generate new static mesh. So I'll click that, and it's created our new static mesh here. And so I'll drag that out into the world, and let's say I'm using this now to build out a level. Let's say I've made a couple copies of this, maybe I've turned them a little bit or whatever it is. And then let's say I decided later on, I wish I had done something a little different with these. Maybe I wish the opening looked a little different. So what I can do is go back to my tool here, and I can make a change. Let's say I grab the handle here, and we'll move this up like that. And now I could go say update static mesh, and it updates all of the instances that I've used in my level. And so, for example, in the Lyra shooter game, they've taken the tools and they just hid them all underneath the map. Basically, if you look underneath all of the maps, there's, whoops, grab the whole tool here. They've moved the tools underneath the map like this. So if you back way out, you can see the map up top and a whole nother, basically another version of the map, but only one really copy of each tool underneath the map. And so that's one way you can do it. You can stash your tools like that. And then there's another step that they've taken as well, which is to go ahead and create the ability to swap back and forth between your generated and your static version of the mesh. And they've implemented some cold storage to allow that to happen, where basically your saved version of the static mesh is saved in cold storage with a unique tag, a source tag that basically links them together to the instances that exist in the world. So they've created a functionality where you can right-click by using editor utility actor. You can right-click and swap back and forth between your generated and your static mesh. I'm not going to get into that in this video. I might do that in a follow-up video. But for now, this basically will get you acquainted with and get you started with how to use the geometry script plugin. All right, well, I hope you enjoyed watching the video, and I'll see you in the next one.